Welcome to the VSCode. I'm Shafu, and today's episode is with Pranesh, who wrote the Solidity Inspector VS Code extension. Pranesh, thanks for taking the time, man.
Of course, it's my pleasure.
Awesome, man. So what we're gonna do today is Pranesh is gonna do a quick introduction what VS Code Solidity Inspector is and why you should use it, and then we're gonna do a quick demo and then jump into the code. Yeah, Pranesh, do you want to start with the introduction?
Yeah, sure. So this is a VSCode extension that I built for fun. So where it all started was from this tweet from Zero Age. So he was proposing a optimization trick regarding and stuff. So when I was trying to use this, I felt that there is like a lot of things that I have to manually do via terminal, and I felt a bit of like quite lazy to do all these stuff via terminal. Of course, terminal is the most handy thing, but at sometimes I feel like if it will be more convenient if there is like we can use it via terminal, via the extension itself or via the editor itself. So what I did was I just created a couple of features. So these were the first three features I introduced in this extension. For my own sake, I was just having it as a private extension, like I was just using it for myself for quite a bit, and then like I open sourced it eventually. Uh, so yeah, the goal of this extension is like to have all small utilities that help Solid developers to enhance their development experience. So yeah, so it supports or it features like small utility functions that can save quite a bit of time. Not much, but quite a bit of time for the developers. So yeah, that's the goal of this extension. And the reason for adding all these features in a single extension is to avoid the fragmentation. Because if we go and search for VS Code extension for Solid, there is like 20-25 extensions out there. So it's quite cumbersome to maintain all these extensions, different in like different versions and stuff. So as long as the size of the extension is small, I try to add more features to the same extension unless there's a specific reason to do it as a separate one. So yeah, that's my yeah, that's the goal behind it.
Nice. You also have
So
syntax
yeah,
hi-
feel free to stop me, Shapo,
yeah,
if you
syntax highlighting for tree files as well, which is nice. Like it's used for BTT, right?
yeah.
Introduced by Paul. Nice, nice, nice.
Yeah, exactly. So it was like built on top of Bullock. Shout out to Alex. It's great work from him. So I just added some support for it as well to instantly generate it with via a single click. So yeah. So let's. This is the README here, and this is all of the documentation that is available so far. I plan to create a wiki page for this extension, but yeah, so it's currently a work in progress. I'll soon create a documentation for it yeah, in the form of a wiki page. So yeah, you can go through this README, and there is like quite a bit of demo here attached in this README, and there is some inside the assets folder as well. And also, as always, this is like fully open source, so feel free to create issues or add new features. I'm happy to review them as well. So yeah, let's dive into the demo first. So this is one of the repo I used to test this extension. So this is like this is a Zuniswap repo. So yeah. So the first feature here, I'll just walk through feature by feature. The first features are creating like these kind of outputs, intermediate representation or like assembly optimized outputs from Forge. So what it does is it displays the ASM or IR outputs in the screen itself. So what you want to do is just right click and search for it and then just click it. So it will create a assembly output for the given contract. So you can see it's all here. It will be like easier if you want to do a gas optimization or you want to see what's going under the hood. So I guess it will be applicable for the repos that are assembly heavy. So the whole point is Zero Age tweeted it for the sake of seaport contract, I guess. So seaport contract is one of the assembly heavy contracts out there. So I guess we can use it for such contracts to do more kind of gas optimizations. But yeah, the goal of this extension is to have it like parallel or like just generate it quickly rather than going to terminal and typing out all the commands out there. So yeah, it just builds on top of Foundry. So I just run the forge command under the hood. No magic. So yeah, same goes for other types of outputs as well. You can do like IR, which is intermediate representation, which is more optimized than the assembly representation. So the assembly representation like does something like constant compile time, constant evaluation, stuff like that. But uh, this IR is more optimized. It does like function inlining and stuff like that. So it's more optimized by code. It's taking quite a bit, I guess. Uh, Maybe the contract is too big. Maybe I'll try to for V2 factory. This is the IR output as well, so you can just go through it as well. So this is like much more readable than the assembly output. So you can see all these functions here, and you
Yes.
can press optimization and like yeah, whatever you wanna do with this. So yeah, the next feature would be to view the storage slots of the given contract. So let's say if you want to see the storage slot of the factory contract, does it have any state variables? No. Let me see. Uh, okay, I guess you can storage layout. So it takes okay. So by just doing this, we can view the storage layout in the
Mm.
editor itself. So you can see it is quite useful for if you want gas optimization as well. Like for example, packing multiple variables into a single slot. You can see here, for example, these three variables are packed in the same slot number, which is 8. So it saves quite a bit of gas. So by doing so, you can yeah do some gas optimizations as well. And yeah, it displays like a easier view or easier method to view in the editor itself. So yeah, it also like inherits the forge under the hood. So yeah, it just runs the forge storage output uh, in with the prettier flag. So yeah, that's how it works. So yeah, so what's next in this? Okay, flatten. So the reason behind adding this is like I felt that the existing flattening tools are like not so user friendly or it was not working for me personally. So I just went ahead and added this function. It also uses force under the hood. If you just run right click and call the flatten method, you can see there's a so you can see there's a flatten as well. So you can choose that and it will just generate the flattened output. Yeah, you can just use it for yeah whatever required, like verifying the contracts or yeah, mostly it's used to verify the contracts. But yeah,
Interesting.
you can use
So
this as
Pranesh,
well.
what are the other flattening tools using in the background? Do you know by any chance?
Sorry, the flattening extension. So I was using Solidity metrics, I guess. So the Solidity extension it also uses flatten, but I feel it is not. See, I was getting some errors as well.
Yeah,
Uh, I don't know. Maybe it just supports stuff. I don't know.
yeah.
I was using that earlier, then it was not working for me, so I want yeah.
Okay.
So yep. So the next one is highlighting of unused imports. So currently, like there is no way of the Solidity compiler doesn't highlight unused import or doesn't throw any error on that. And it might be like more efficient if you don't have unused imports in terms of the compilation times. And also it's like a best practice not to have unused imports in your code. It makes your code more clean and readable rather than like cluttering your imports. So I
Yeah.
was just like when I was writing a project, I was having a lot of unused imports without even my knowledge. So then I had to all clean them up manually, like just searching if they are used anywhere like that. So I was pissed off, and then I just added a similar unused import like in inline rating of unused imports so that it helps others as well in order to clean the imports. So how it works is you can just let's say if you want to import like a factory contract. So you just need to import and save your file and it will just get highlighted with a tooltip of unused imports. So you can just go ahead and delete it. Sorry, we can also import a router contract as well. So you can see these are the unused import contracts. For example, if we try to import math, it should not be highlighting as an unused import. So yeah, it just checks for unused imports in the current file, and yeah, just highlights it so that you can just remove it, and it might make your code base compile faster. So if your code base is too big, and it might save a bit of time, I guess. So I guess I just added it to save some time during compilation. Uh, so it just works for the current file. Let's say if we Solidity actually supports import from multiple files. Let's say if we import math in the spare contract, and we if we import this Uniswap pair contract in the router contract, you can already use math without importing it in the router contract. That kind of dynamic, that kind of imports are not like tracked currently because it might slow down the extension. So currently it will be the high import of unused import highlights will be only used for or only works for the current Solidity file that is active. But yeah, it's I guess it's down the roadmap. I'm planning to support such cases as well.
Nice. Pranesh, what are you using to detect unused imports?
Sure. For unused imports, I'm the logic is pretty simple. So what happens is it just checks the occurrences of the imports, right? There are two types of imports. I mean, like there are three types of imports in Solidity. So one type is without unnamed imports, right? So in this case, it uses this contract. And the second type is named imports, which is way cleaner. That uses ERC20. I guess this is the one that we are supposed to use. The another type of import is like aliased imports, like we can import math as fixed math, right? So here we will be using fixed math as the imports. So you can see the fixed math hasn't been used here. So it highlights automatically. So the thing is, I'll be just counting the occurrence of the imports. If it is like less than for example, for named imports, it should be less than the occurrences in the import statement itself. For example, the occurrences of this will be like if it is like one, then it is an error because in this case there is only one import, and if it is not used anywhere else, then it will be only one. And in this case, the occurrence will be two. The number of occurrences in the import statement will be two because ERC20 is here. And at the same time, uh, if the occurrences is equal to the occurrences in the import statement, then it is an unused import. So that's the logic I'm using.
Mm, okay,
Yep.
nice.
So yeah, also I'll be using pattern matching for comments as well. There is some edge cases that there are some same ERC20 or some other strings be mentioned in the comments as well. So if it's a comment, then I'll ignore it.
Mm,
So yeah. Also, the thing is, it is also like compatible with solhint. For example, the solhint rule, like solhint, disable unused. I guess this is the rule, but I'll double check. So let's say if we try to import math as something like this, I guess I need to check the rule. So yeah, this one. So if this rule is enabled, there will be no unused input highlight will be there because the user doesn't want to see any highlights of unused inputs. So I added this rule as well. It was a feature request, so I implemented it, and yeah, it makes sense, right? So yeah.
Yes.
So the next feature would be, so yeah, I guess this is my favorite one so far. And yeah, because for example, there are like Foundry's broadcast files which are the deployment scripts outputs, and there are a lot of times during documentation I might wanna find the addresses of the new contracts and verify the deployment file as well. After, let's say, if there are some methods that is called the deployment script for configuration post deployment, I'll need to verify it as well. So I had to do it manually every time with the Foundry output, which is not that clean. So I created a simple tool to just view it in a clean and concise table format. So this will be the output format from Foundry, and if we use this, right, it will be in a table format. So you can see the new deployments, the hash, the contract name, and the contract address. So it detects the network from the net chain ID from the output folder, and you can easily export this by just copying it and adding it in a GitHub PR or whatever you want to do. And then it also
Yes.
tracks the contract calls, which is like calls made in the deployment script. For example, it tracks the caller. It's because I zoomed in. If we like zoom out, yeah, it will be much cleaner. So yeah, you can see the caller address and which contract and what is the function it called and what are the arguments passed. So for example, it called set factory or set deal source in this factory contract by this caller, and these are the addresses passed. So so this is like we can simply just copy it and just pass it as to the to your teammate or like to whomever you want to share the deployment result, rather than just uploading this JSON file, which is not that clean. So you can simply use this uh, status bar item, or you can just right click and click generate deployment report
Mhm.
from this context menu. So it's quite handy. Yeah.
Yes. Yeah,
So next one is the syntax
I
highlighting of
always
dot free files.
I
So
always used a custom Python script that I wrote for this. So it's nice to have an actual, you
hmm,
know, to, yeah, yeah. I have like a Foundry
yeah.
template that I always use with a little Python script in it to print out the addresses after deployment. In my opinion, they should add this to Foundry, but it's nice to have it in your extension.
Yeah, I guess yeah, that would be great
Yeah,
if they have it in Foundry. I can also like create a PR for that, but if there is demand, so yeah, that's a good
I
suggestion.
I think there's an issue for it. I'm pretty sure.
Yeah, I guess we can add a flag after deploy of the script like summary or something like that to view this table. Yeah, that's a
Yeah,
good suggestion.
exactly. Yeah.
So so yeah, so the next feature is, so any questions so far, or can I just get going?
Let's continue.
Okay, cool. So the next one is the syntax highlighting of .tree files. So the .tree files, you guys already know the branching tree technique from Paul. It's already like widely adopted in the industry, and it works pretty well as well. So I guess I suggest everyone to use the branching tree technique as it is like a more standardized, and it helps find like a lot of edge cases as well. So I added when I was working with BTTs, it was like quite boring because the the output was like in bland white text. It is not such appealing. So I just wanted to like add quite a bit of coolness to it, I would say. So you can see it is like just colored. You can see the keywords are highlighted and these branches are quite like it looks appealing, at least for me. So I guess I added this kind of syntax highlighting support for the .tree files. Uh, so yeah, if you can, we can add or edit it, and it will automatically create a new. Yeah, so yeah, like it will automatically check for the keywords and highlight it, and it also throws some error if we use a non-keyword or like it's plain so if you hover over it, so it shows this error. So
Mm.
it's like a small error handling as well, so
Nice.
that the node should or the node should with this keyword. Yeah, so yeah, that's this syntax highlighting feature for this tree files. And yeah, as we talked about it earlier, I added the Bullock scaffold support as well. So we can create Solidity test stub using, sorry, Foundry test stub using Bullock just via a single click. For example, if you want to create a new contract test stub with for this tree file, we can just right click and click on the scaffold, and it should create a new test stub for you. Rather than doing it via terminal, you can just easily do it via your
Nice.
editor. You can just save it and yeah, and use the test stub created. And yeah, all the heavy lifting was done by Bullock. It's just like I integrated it with this extension.
Mhm.
So yeah, the next feature is auto completing of import paths suggestions. So yeah, when the code base usually grows big, it becomes a pain to import files manually to remember all the paths and stuff like that. So I created a small utility that helps users to automatic help that suggest to the developers the import path when they just type import. For example, if we want to import something from Solmate. So what we can do is, let's say we want to import auth, right? So we can just type import auth. It will directly show the suggestion as they type. So I guess this is very useful if the code base is big. And the cool feature is it also tracks the remappings. So you can see it automatically fetches the soulmate path from the remappings and replaces it with the actual path. So I guess it's also quite cool to do so that the import paths are more consistent and clean rather than more cluttered. And yeah, import. Let's say if you want to import something from the local file as well, you can do it similarly. So yeah, you can see it prefixed with the src rather than uh, in this format. So that it helps you to track actually where the file is coming from. So the path is more cleaner. So this is the latest one of the latest updates I pushed recently to replace this format to this format so that the path is more cleaner.
Mhm.
And it also tracks remappings as well. If let's say if you change the remapping or install new dependencies, uh, we can let's say the soulmate if you want to remove the at the rate of in front. So you can it will be if you press the hotkeys like command option X, it will be like refreshed so that it tracks the new remapping. So import math. Oh, so import auth, right? So, So you can see that the rate is been like removed now. So it tracks the latest remappings now. So yeah, if you it is very very helpful if you add new remap or new dependencies to your project like OpenZeppelin or any other new dependencies on the in the future. You can just refresh your remappings using this key bindings and then like you use this auto import feature. Yep. So that's why I added this option to refresh the remappings.
Mm.
And so yeah, the next one is inline code separator. So this is more like I would say a fun feature as well. So sorry, I guess some would have been missed. I missed the import ERC. Okay. So let's say I need to add a separator to my code, and there's like a lot of other separators as well. But we need to standardize the separators as well to make it more consistent with the industry standard. So I added mostly used separators. One is Soulmate and Solidity, which I personally like. Those are the two separators I like to use in my code. I don't like these kind of separators. I know this is just for like someone added this for the sake of separating the private functions with the external functions. But I'm saying that we need to, if there is an easy way to add this, we wouldn't just go with some random separators that we want to do. So it will make it more consistent. For example, if I want to replace it with it with a more consistent separator, I would do like I will type 4 backslashes and it will give me two suggestions, either Solidity separator or Soulmate separator. So if I press Soulmate separator, just enter it and you can just write private, right?
Nice.
So yeah, I mean it's quite fun to add these things. Uh, so yeah, so you can
Do
see that.
you, Pranesh, do you personally use the separators?
I do use it. I do use it. I like having separators. It adds more readability to the code. So I prefer having it. I mean, like, why not?
Yeah.
So yeah, you can also like collapse. The feature I like with Soulmates is it's collapsible with editor as well. You can collapse it. So it's if you can if you want to. So that's yeah, adding separators is quite opinionated, but I like adding it. So I created a small utility to save my time. Otherwise, I will need to go to Soulmate's repository and then copy and paste it to my code every single time and edit it.
Yeah.
This I guess saves some time with that. So yeah, the last feature, but not the least, is this contract size code decorator, inline decoration. So you can see the contract code size inline as well so that you know when you are going to exceed your contract bytecode size limit. Uh, so what it does is it reads the compiled output from your out and then like fetches your bytecode and then like based on the bytecode length it's calculated. So this is how the size is generated in other frameworks as well. For example, let's do like codes will oops. So you can see Newsop V2 factory is 9613 and it's 9.39. So yeah, so it's almost closer. Maybe it's because I'm converting it. I'm dividing it by 1024. So single 1 byte is 1 KB is for 1024 bytes, right? So it displays in bytes. I'm displaying it with KB. So yeah, that's the difference here. But both are literally same. So maybe we
Mm.
can confirm it, right? So 9613 divided by, so yeah, 9.387 KB. So yeah, that's what being displayed. yeah, that's the last feature, and it is also like it's green because it's less than 20 kbs. So if it is more
Mm,
than 20 kbs, it will be in orange, and if more than 22, it will be in red, so that you know you are going to exceed your size soon.
nice.
So yeah, the goal was to use Solidity compiler and display it on every generated on every save or on every code change, but I couldn't get up to this performance that I wanted. So this is still a work in progress, I would say. Currently, it depends on the output after compilation, but I would like to have it in real time as well. When we make changes to the code, when we save it, it should recalculate and display the bytecode size. So yeah, that's part for in the future. So maybe I'll get back to it in
Yeah,
the
but
future.
yeah,
Yeah.
as you said, yeah, performance-wise would
So
be you. Do you want to really recompile after every save, especially if it's a bigger project, doing
actually,
IR stuff?
what we can do is we can forward build in watch mode, right? So for example, if we try to remove this, right, and save it, uh, maybe after saving, you can see it is changed here. So if you
Hmm.
add it back in, right? So once the compilation is finished, you can see it has been changed again. So you can run it in this watch mode to get like instant idea of
Hmm.
what's your bytecode size looking like. But yeah, for now, this is the only thing I can think of for getting a real time bytecode size. Uh, but yeah, at least it helps. A lot of times I just try to write all the features in a single contract and then like face this bytecode issue. Then I'll be moving things here and there, and it takes a lot of time. So if it is something, if there is something like this, then I will know beforehand, and it saves me a lot of time in the future. So I guess that's why I added it here. And you
Yeah.
can also disable it if you want. For example, let me close this. Why do I close it? So I can just pause it, and if I oops, yeah, if we just go to if we can just go to settings, extension, sorry, settings, and search for Solidity inspector, or just search for inspector. So there is an option called show contract size. So if we just disable it, it should go away.
Hmm.
So yeah, it's gone. So if we want, we can enable it, and it should come back. So yeah, if we find it annoying, you can just turn it off. Yeah. So yeah, that's the demo, and yeah, there is like the recordings of the demo here as well in the README. So feel free to check it out, and yeah, also like as always, contributions are welcome. Now I can dive into maybe some parts of the code if you like to
Yeah,
learn about.
let's
So I'll just
let's
stop.
look under let's look under the
Yeah,
hood. Let's see how the contract size features implemented, for example.
yeah, sure. I guess I had a yeah, it's here. I guess this should yeah. So here is the one. So this is the flow. Can you see it? Maybe I can. Is it visible?
Perfect. Perfect.
Yeah. Okay. So what happens is So it works for only the current file, right? So based on the current file, you can fetch the contract file name from the VS Code extension API itself. And it's as the contract code says, works for both hard hat and foundry projects. What happens is the code first checks if it is a foundry project or hard hat project by checking the config file, foundry.toml or hardhat.config files in the root repo or the root directory. If one of the configs exist. For example, let's say if the foundry config exists, right? So what happens is you can specify the output directory in your foundry dot toml config. Like let's say we can map out is equal to like some names or what directory you want the output files to be, right? So what it does is it parses it reads the config file and finds out the output directory name, and it enters the output directory name and checks for the contract name from this extension API. And once the file exists, it reads the artifact file and parses the JSON output and check for the deployed bytecode object. So once the deployed bytecode object is present, it just removes the 0x prefix and calculates the length and divides it by half. So that's how the contract size works. So it's just the bytecode length uh, of the contract. So yeah, so once it is done, it will just return the contract size. If there is if the bytecode object is missing, it just skips. And if there is no build file found, it just skips as well, returning an artifact not found internal error. And
Mm.
same goes for hard hat. If it's a hard hat project, it just checks for the artifacts file, artifacts directory, and then goes into the artifacts directory and traverse down the output file and then like does the same. It extracts the parse deployed bytecode and then it does a length calculation as well. So I can display the you can go to the code as well. Where is it? Contract size. So yeah, I mentioned I fixed the default Foundry output directory as out and hard hat output directory as null because it will be recursively checking for the output directory. And so these are just the decorations design. I mean like the margin and the properties of the text, like the opacity and stuff like that. So so yeah, it just checks for if it is a script or text, it will be like ignore it because we don't want to check the size of the contracts for us if it is a script or test. Even the script or test file start with the keyword contract, so we don't want to calculate it. So yeah, it just checks for foundry config and it just checks for hard hat config and finds the artifact recursively using a file system traversal. And once we get it, we can use this regex to find the contract, the line, which line we need to display, right? So we need to display the same line as contract x, something like that. So we need to display so this is used to find which line the contract is, and it fetches the position, how big the line is and where we need to display. So once it is found, we can fetch the contract sizes based on the bytecode length. So what it does is once it fetches the JSON, so it fetches the JSON content and then checks for the deployed bytecode object, and then it just divides the size by 2 to find the length of the actual contract, I mean size of the contract. So once the size is calculated, we can just go ahead and format it. So you can see the bytes, it will be in bytes, and if we divide it by 1024, it will be in kilobytes. So it just formats it, and then like so yeah, as I mentioned, if it is like before like less than 22, it will be less than 20, it will be in green. If it is more than 20 and within 22, it will be in orange, and after 22 kilobytes, it will be displayed in red. So yeah, I guess green or orange and red. Yeah.
Mm.
So yeah, these are the colors that will be displayed in your code. So yeah, that's how it works.
Nice, nice. Yeah, one last thing I want to look at is
Yeah.
how you implemented the unused imports. the
Hey, I
unused.
can't hear you. Can you hear
Yeah,
me?
yeah,
I
yeah.
guess
Can
I
you hear
lost.
me?
Yeah, yeah.
Yeah, I was saying the last thing I wanna
Yeah,
wanna
I can
look
also
at
walk
is
you through the.
the unused imports. How we implemented the unused imports.
Yeah, sure. So unused imports is kind of same. I guess I have a flowchart for it as well. Just yeah. So yeah, it's basically what happens is based on the uh current active file, it checks if there is a solid disable this rule. If there is a rule existent, then we just skip everything and then just don't display anything. If there is no such rule, we extract the import statements using pattern matching using regular expressions. As I mentioned, there were like three types of imports we can do in Solidity. So yeah, so it just extracts the import statements and also file extracts the actual import from the import statements. And then we just loop through all the exported imports and check the occurrences of the imported items. And if the occurrences of the imported items is equal to the occurrences of the imported items in the import line itself, then it is an unused import, or else it has
Hmm.
been used somewhere else. Yeah, if it is, then we just highlight those import lines specifically. So, so yeah, we just add the range as well to the using the VS Code extensions API, and then like we just do some decorations over there, which is a overlay of red highlight. So I can also walk you through the code. So yeah, you can see the extract imports, or like it extracts two kinds of imports. One is for items and another one is for files. For items based, so items in the sense, so these are the kind of imports I'm talking about. So if it is an import ERC20 from X, right? So this is this regex used to find these kind of imports, or this also works for like these kind of imports. The file imports or something like unnamed imports, which is like import. So these are like unnamed imports. So these are two regex that helps to match these kind of import statements, and once they are matched, those will be like returned, like pushed and returned as a part of method. And so yeah, so this is the entry point of the function, and all it does is it first checks for the rule that I mentioned earlier. So if there's a rule, then just ignore and return. Don't do anything. If not, it checks for the import statements, and then like after import statements, it fetches all the import statements, and it passes each import statement into this extract import methods, and the extract import methods will checks for these two kind of imports and then returns the import items. And for each item, we loop through all the items, and yeah, it checks for occurrences. So it checks for total occurrences in the import statement, and it checks for total occurrences in the overall file. So if both are equal, then we just add the range, and then like use the update the decoration with the hover message of unused import. So so yeah, that's how it works, and we finally set the decorations based on the
Hmm.
properties we populated earlier. So this happens for every save that you do. Like whenever you save the current file, these things happen. So that to make sure you have used the import in after like latest change or something. So so yeah, that's how it works. And yeah, any questions?
Nice. What are some features you wanna implement in the future?
So I guess there are quite a bit, but I just need to have a solid vision if I actually need them. I guess there is like a lot of backlogs that I want to implement, but
Hmm.
either they are like quite like too big that might slow down the entire extent, extension, or they might need a new extension themselves. So I'm just trying to not make sure not to overkill, like to make the have the extension lighter. So I wanted to find the features that is like useful for developers, and also like uh like lighter or easier to implement as well, so I can add more features to the extensions. So yeah, I'm thinking of integrating like gas uh, inline gas consumption messages for the functions, and yeah, like quite a bit of small utilities. I don't remember on top of my head. I have it all written down somewhere. Whenever I think of something, I just capture it in my notepad. So yeah, there's quite a bit of features that I'm currently like slowly working on. And yeah, as I mentioned earlier, I want to make the contracts code size like real time. So whenever a code change has been made, I wanted to display the current code
Mm,
size. I guess it will be more useful rather than trying to run the entire case with the watch mode. So
nice.
yeah, I guess these are the priorities in the near future.
Nice. Well, Pranesh, thanks for building this, man. It's a great tool. I'm gonna put the link to the GitHub, the link to the extension, the link to your Twitter in the description down below. Pranesh, thanks for taking the time, man. This was very interesting.
Yeah, thank you so much for having me. And as mentioned earlier, feel free to suggest if you guys have any ideas, or if you guys run into any issues. I'm happy to look into it.
Awesome, man. Then thanks, guys, for tuning in, and I'll see you in the next one. Bye bye.